problem 20 of Neetcode 150, slotting window maximum. Okay, so in this problem, we're going to be given an array of integer and also a value of k, and that value of k is basically the length of the window that we're going to have to use. We are going to have to use the same window for the entire problem. And the problem itself is not super complicated to understand, but when you actually try to figure out a solution in big O of n time, you'll see that it is quite complex and not obvious at all. All right, so the problem goes as follows. Let's just take the example one. So we have a k value of 3, so we are going to have to use a window of length 3. And we're gonna have to move it by 1 every time and take the maximum within that window. So you can see that here, the window is the three numbers highlighted in blue. So you have 2, 2, and 4. Oh, hold on. The okay, sorry. So the first three numbers here are highlighted in blue. 1, 2, and 1. What is the maximum? It is 2. So we are gonna happen to the output array 2. Now we're just going to move by 1 here, and we're going to still have 2 as the maximum value in that window. So we are going to add 2 here. We're going to move 1, 0, and 4. The maximum is 4, so we are going to happen 4. Now we move again. We have 0, 4, and 2. The maximum is still 4. So we're going to happen 4 to the output list. And finally, 4, 2, and 6, the maximum is 6. So we're going to happen 6 to the maximum as to the output list. Okay, so one solution that comes to my mind is that we just we first set our initial window. We take the maximum by using this. All right, okay, and then we take the second window and we just take the maximum here, and we do this for every other windows. And you see, it takes about 5 lines of code, and it renders the correct answer here. Okay. Because if we do it with our own brain, we see that here the first number should be 5 in that first window. In that second window, the number should be 7. In that third window, it should be also 7. And in that last window, it should be 9. So this solution gives the right output. But the thing is that with that brute force approach, we get a time complexity of big O of n times k, because we have to recalculate the maximum for every single window. So there is a more efficient way, and this way make use of the DQ. So what is a DQ? A DQ stands for double-ended queue. It is a data structure that allows adding and removing elements from both ends. So basically, it's like a stack plus a queue, right? So you can have first in, first out, and last in, first out. So you can add from the beginning, you can remove from the beginning, you can add from the end, or remove from the end. And we can see here that popping from the last element or popping the left element both uses time complexity of 1. So this is something interesting. You might not get the reason we want to use this or the utility of the DQ yet, but you will see that it is quite useful, but the solution is not obvious, as I mentioned, and we have to be wise to understand the process of it, because it is not intuitive. Okay, so we're going to have to use our sliding window. This is our DQ. I even had an arrow to make sure that we don't confuse this with the numbers above. Okay, so we have our K, we have our array here, our example array, and let's just put our left and our right indexes, our left and right pointers to the element at the index 0. It is 5, okay? So first we have an empty array, so we are just gonna add the index, and this is important. We are gonna add the indexes inside the queue, not the value itself, okay? So we're gonna add 0, and then there's not much we can do after this. So we are gonna move our right pointers by 1 to the right, and we have 3. We have to to make sure though that we maintain a monotonic decreasing order, meaning that the numbers in the array have to be decreasing. Like you can have like 5, 3, 2, and then 9 or 8. It has to be constantly decreasing. Okay, you will see why. Let me explain you. So we will check the value of the array at the index of the right pointer. Here, the index of the right pointer is the index 1, so the value is 3. We want to check if 3 is smaller than the numbers that is at the um, foremost right in this queue. There is only one number, so we want to check if basically 3 is smaller than 5. It is the case. So acknowledging that this statement is true, we are going to add the index, okay? Um, and now we're gonna keep moving. We have 2. Same concept. Is 2 smaller than 3, which is the not the element to the right of the queue? Yes. So we are gonna add our 2, okay, which is the index of the right pointer at this moment. But we also have to be careful here because the window cannot exceed a length of 3. So a statement that we are gonna have to add in our algorithm is we're gonna have to check first if the right pointer plus 1, so the index of the right pointer plus 1 is greater or equal than k, because you see here the right pointer is at the index q, and we have actually a substring here, a sub array that has three elements. So it has a length of 3. So we cannot move our right pointer to the right without moving our left pointer to the right as well. So if this is the case, we're gonna take the value of the array at the index of the at the left index of the queue. So this is index 0. So we are gonna add basically 5. Okay. We're gonna add 5 to the output array. And we are also gonna then move our right and our left pointer. And one thing that we want to check is um, we have to make sure that the value of the index of the left pointer is not greater than the index at the left of the DQ, because otherwise there's a chance that we add a number that is no longer in the window. So if the left index is greater than the index at the left of um, the queue, we are gonna have to pop it from the left. So we're gonna take our 0 out of there, and we're gonna append our 1. No, we're not gonna append a 1, but we're gonna move our numbers to the left. Okay. And also now notice that the the right pointer now points at the index 3, which has a value of 7. But remember our initial condition that we need to have a monotonic decreasing order in the DQ. So 7 here, which is bigger than the value of the array at the index 1 and 2, has to be at the most, it has to be at the left, right? So we're going to have to pop out 1 and 2 to make sure that the left element is the biggest one in the DQ. So we are going to do this. And now notice there is only one index in the DQ, and we went through all our if statements. Oh no, we didn't do this if statement, right? So we are going to check, no, we are going to move our right pointers and our left pointers to the right. And this is where we are going to check if basically the left pointer, the right pointer plus 1 is greater than k. So once we pass the second index, this statement is always going to be true. So we are always going to pop out the value of the left index. So here it's 3. So we are going to add 7. Okay. And notice how the output array starts to look like the one that we had in our initial example here. All right, so now we have a value of 4 at the index 4. So this is smaller than the value at the index 3. So we are going to add this index here. And once again, the value of the right pointer, of the index of the right pointer, plus 1 is actually greater than k. So we are going to have to pop again, or we're not going to pop, but we're going to happen the value of the index at the left, so 3. So we're going to add this. Um, so we are going to add this to our output array. All right. Then we're going to move again our right pointer. We are also going to move our left pointer to the right. And now the value at the index of the right pointer, which is 5, is actually greater than the values at the index 3 and at the index 4. So we're going to have to pop them out and add this index. Okay. And now like the right pointer plus 1 is greater than k, we're going to have to append 5. Well, the value of the array at the index 5, so it is 9. And that is it. We have our answer. So I know the solution is really not obvious, but let's try to code this. All right, so first thing that we have to do, let's create our output array, okay? This is great. Now we're gonna have to create our DQ, and in Python you can simply do DEQE like this, and you have your DQ, and we're gonna have to initiate our left and right pointer to 0. Great. All right, and now we're gonna loop until the right index is smaller than the length of the nums. So while right smaller than the length of nums. Oh. Okay. So the first condition was to make sure that the queue is maintaining a monotonic decreasing order. So first of all, we're just gonna have to say while queue. So while there is any element in the queue, otherwise it is an empty queue, and we're just gonna add the index in it. Okay, and also the value of the last element. So we're gonna do -1 to get the last index. Right. So while this is smaller than the nums. So what do we do while basically the last index of the queue is of the DQ is smaller? We are gonna pop from the DQ, so we're gonna remove the last element. All right. Once this is done, we can confidently append it. So we're gonna append to the DQ or right index. Okay, and now this is where we want to check if basically the the left index value is greater than the left index in the DQ, because if it is the case, it means that the left index of the DQ is actually now out of the window. So we are gonna have to pop it out of the DQ. So we are gonna say if the left is greater than the DQ at the first element. Okay, we are gonna say q dot pop left. Okay, this is how we pop from the left in the DQ in Python. Great. Okay, and lastly, do you remember our last if statement? It was if the value of the well, if the right index plus 1 is greater than k, we are gonna happen to our output list basically the value of the nums at the index of the, well, at the left index of the DQ. Okay, so we're gonna say if um, the r plus 1, so if this is, well, basically greater or equal to k, all right, we are gonna append to the output um, the form, the left element, which is going to be the greatest because we're using a monotonic decreasing order. So we know for sure that the left element is the greatest one. So we're going to append it. And we also know for sure that this element is not out of range because of this check here. So we are going to append to f nums at the index of um, q, because remember that the q only holds the indexes. Okay, and now we're gonna move our left pointer also by 1 to the right. This is the moment we do this, and after this we also have to move our right pointer to the right, well, basically every time. And see, it is not more complicated than this. So we created our output, we create our DQ, we initiated our left and right pointers to the element 0, and basically while the right index is within the length of the nums, we are going to check basically if the last element or the rightmost element of the DQ is small. Is, well, we want to make sure that this left element is greater than the right element, okay, at every position. So if it is not the case, we're just gonna pop the last element, and we're gonna keep doing this until we have a left element greater than the right element. After this, we're gonna append it to the queue. Now we're gonna check if the left index is greater. So if it is greater, it just means that that left element is running out of the window. So we are gonna pop it up from the left. And after this, we want to check basically if the right index plus 1 is greater than k, meaning that we have a windows of 3. So at this point, we're going to have to add the element that is at the left of the DQ, and then move our indexes, well, the right and the left pointers to the right. Okay, and after this, we can return the output. And if I didn't do any mistake, this should run perfectly. Great. So I hope you learned from this video. This is not an easy problem. In fact, it is a hard problem. So make sure that you understand the role of the DQ in this situation. And I hope to see you in next video.